Then we're going to proceed on the relative volatility of the mixture. Okay, mixture of A and B. Remember, just now I mentioned about your mixture can be a mixture of liquid, okay, a mixture of vapor, or maybe a mixture of liquid and vapor that are considered as condition of the feed. Okay, condition of the feed. So when you talk about relative volatility of the mixture, okay, so this is very important because you should know the advance or the beginning or the initial information before you before you decide to use a distillation process or not. Okay, so this relative volatility calculation will give you the initial information whether to proceed or not to proceed on the distillation process for your mixture or not. Okay, because you have other alternative, you can use gas absorption, maybe you can use liquid extraction, maybe, okay, other than distillation. Okay, maybe majority of the process, maybe you would like to avoid using distillation, okay, because when you talk about distillation process, the cost is much higher. Okay, the cost is much higher compared to the liquid extraction or gas absorption. Okay, this is due to the heat energy used in the process. Heat energy used in the process. Okay, all right. First of all, definition. So we are talking about what is the definition of volatility of a mixture. This is the ratio of the concentration of A in the vapor, okay, to the concentration of A in the liquid divided by the ratio of the concentration of B in vapor to the concentration of B in liquid. So you get this formula. Okay, you get this formula to get your relative volatility of mixture AB. Okay, all right. Or you can use partial pressure of pure, okay, pure A and pure B also. So you can use equation 3 or equation 4 to get the value of your alpha. So relative volatility of a mixture is given by a symbol of alpha. Okay. All right. And then, okay, from this equation, so you can play around. From this equation 3 and equation 4. Okay, not equation 3 and equation 4. Okay, so you can play around with equation 3 and equation 4 and come up with another equation, which is, this is one way of you to find the mole fraction of vapor A using relative volatility of a mixture. Okay, remember just now how you can calculate YA? So this is, you can use equation number 2 to calculate YA, or you can use Dalton's law to calculate YA. Okay, or you can use you can calculate YA using relative volatility terms. Okay, so there are two ways to calculate YA, which is mole fraction of a vapor A. Okay, so you can use this equation if you know your alpha. Okay, if you know your alpha. So maybe you are given in the questions, you are given the mole fraction of liquid A and only one alpha given to you. Okay, therefore you can calculate YA corresponding to XA that you have. So if you want to find YA1, you use XA1, XA1. Okay. If you want to find YA2, you're going to use XA2 here and XA2 here, where alpha is constant. Okay. Why do we need to find alpha? Okay. Why do we need to find alpha, or relative volatility of a mixture? So this relative volatility of a mixture will represent whether you're going to have a good separation process or poor separation process. So this distillation distillation process that we use is just for the separation process. Okay. Sometimes it's not easy to separate a mixture of liquid A and liquid B. Okay, sometimes it's not easy to separate two components, which is A and B, in liquid form. Sometimes, because of that, you might want to use distillation process. Okay, so let's look at this one. When the value of alpha is bigger, you're going to have a good separation process. But when your alpha is very low or small, you're going to have poor separation. Okay, so this value of alpha can give you the result to make decision whether to proceed on the separation process using distillation column or not. Because the separation, if you have a good separation, then you can proceed with the distillation process. If you are going to have a poor separation, maybe you don't want to use distillation process. So what is considered as good separation or poor separation? If you have a value less than 1, okay, you're going to have poor separation, okay, which is not advisable for you to proceed with distillation process. Therefore, it's good to have this alpha value, because you don't want to start the experiment, you don't want to start the process using distillation column, okay, distillation process. Towards the end, you find out that you won't get that good separation. So the separation occur is not to what you want it to have to be. Sorry. Okay. So better not to proceed. So this value of alpha will give you the good decision, okay, before the cost can be incurred. Okay, so this is what we have to do. We have to forecast first what will happen in future. So don't do first and then figure out later. Okay, this won't happen in chemical industry. Okay, so you need to know, you need to design first whether it is possible or not possible, and then you proceed. Okay, right? Or maybe you can have other alternative, right? Okay, if you have a value of alpha greater than 1, can be 1, 2, 3, 3.5, 6, 8, it doesn't matter. If you have a value higher, bigger than 1, you might have a good separation. Okay, the higher value of alpha that you get, you're going to have a better separation. Okay, so this is the indicator. The value of alpha can act as indicator. Okay, all right. Okay.